Hello there, this is JP Eustaquio of MEE21, and this is Basic Electronics Engineering Experiment Logs. So let's go straight to the video. So in this video, we are going to talk about experiment number 5, which is this. Experiment number 5, diode application. Voltage regulation using a Zener diode. And here are the objectives. First is to understand the characteristics and operation of a Zener diode. Second is to distinguish the difference between a loaded and unloaded regulator. Third is to determine the effect of changing loads in a regulatory circuit. Fourth is to determine the effect of changing input voltage in a regular circuit. Fourth is to observe how a Zener diode function as a simple voltage regulator. Sixth is to distinguish the difference between a Zener diode and rectifier diode. And in this experiment, we are going to again use multi-sim. But for additional information, here are the equipments and components that I'm going to use. First is 1 voltometer, 1 digital multimeter, 1 Zener diode, 5 volts, 1 watt, 1 DC power supply, 1 100 ohm resistor, 1 330 ohm resistor, a 1 4.7 ohm resistor, 1 breadboard, alligator clips and connector wires. And we are given 2 figures 1 and 2. And here are the procedures given to us. First is to connect the circuit shown in figure 1. 2 is to turn on the power supply and slowly increase the applied voltage until 5 voltage appears across the Zener diode. And then measure the applied voltage and record the value in table 1. 3 is to measure and record the total current in table 1. 4 is to measure the voltage across RS and record the result in table 1. Then calculate the current through RS and record the results in table 1. 5 is to increase the applied voltage by 2 volts and repeat steps 3 to 4. 6 is to increase the applied voltage by 2 volts and more, and repeat steps 3 to 4. 7 is to connect a 4.7 kilo ohm load resistor across the Zener diode as shown in figure 2. 8 is to repeat steps 2, 4 for the circuit with 4.7 kilo ohms load connected. Turn off the power when you have finished. 9 is to repeat steps 2 to 4 for the circuit with 100 ohms load connected. Turn off power when you have finished. 10 is to remove the load resistor and connect the Zener diode in opposite polarity. Vary the power supply voltage between 0 to 10 volts and measure the voltage across the Zener at 1 volt intervals. Also measure the current IT and record the result in table 2. But first, I'm going to show you the multi-sim of figures 1 and 2. As you can see here, there are 2 multimeters. Each figure, the first multimeter is an ammeter, the second is a voltmeter, and this is the DC power source, resistor, and the Zener diodes. So here are the data that I have gathered. Table 2. Procedure, steps 2 to 4, 5, 6, 7, 5, 6, 8, and 9. The measured volts is 5, 5.001, 5.006, 55. The supply voltage has 2 intervals, so 10 volts, 12 volts, 14 volts, 10, 28. And here are the measured and calculated. And the measured volts the RS. So the first question: how does a Zener diode act when it is connected as a voltage regulator or as a protection device? A Zener diode makes the output voltage of the circuit limited to its forward voltage. The second question: what was the purpose of the series resistance RS in the circuit? It limits the current running across the circuit. Third is, what is the effect if a 100 ohm load resistor is used instead of a 4.7 kilo ohm resistor? It needed a larger voltage source if a 100 ohm resistor is used. It has a voltage input of 28 volts, and it only requires 10 volts input voltage if a 4.7 kilo ohm load resistor is used. So, what are the effects of increasing the voltage to the Zener diode, to the load resistance, and to the series resistance? For the Zener diode, nothing will happen to the Zener diode, regardless the values of the output and input voltage. For the load resistance will need to be increased if the supply voltage is increased. Third is for the series resistance. The series resistance could also remain the same, regardless of the value and the supply voltage, same as the Zener diode. So here are the data that I gathered from table 2. The supply voltage 0 to 10. So first question: how does a Zener diode act when it is connected in the forward biased manner? A forward biased Zener diode allows large amounts of electric current to pass through and offers small resistance compared to a reverse biased one, where it limits the current flow, which leads to a low voltage output. Second, last question: explain the difference between a Zener diode and a rectifier diode. A Zener diode limits the voltage that can pass through whenever it is in its usual reverse bias configuration, while a rectifier diode allows current to flow in one direction, and the values in a rectifier diode refers to the maximum current that can pass through and maximum voltage that can be applied before breakdown. So in conclusion, the student engineers learned that Zener diodes is a voltage regulating module, which can be used in devices that need only a specific amount of voltage output from a larger voltage source. This can be used in devices that avoids overvoltage and that wants to avoid overvoltage and electrical surges. So that's it for this video. Thank you for watching experiment vlog number 5. So stay safe, take care, and again, thanks for watching.